Hey everyone, welcome to Webbox AI channel. In this video, I will show you how to use LAM, a versatile interpretability technique, to understand the model's output on NLP tasks. The first thing is we will go through some of the basic knowledge, how the technique works, and then see how to apply it for text data and natural language processing tasks. And finally, we will go through a concrete sample and see how we can implement the technique in code. Now let's begin. So what is LAM? LAM stands for Local Interpretable Model-Agnostic Explanation. The local term means that this technique is used to interpret the output of a single instance, in contrast to global, which will interpret the model on the whole dataset. And by model-agnostic, this technique can be used to explain the predictions of any black box classifier, regardless of their internal architecture. So it treats on the classifiers as black boxes. Under the hood, it works by first it could generate the bottom samples of the original instance and observe how the predictions of the model change accordingly. And the final step is to fit a simple model on the dataset we just created. This technique is very versatile and it can be applied for various types of data, from tabular to image. And in this video, we will focus on text data or for NLP tasks. So the LAM technique originates from the paper in 2096 called "Why Should I Trust You?" explaining the predictions of any classifier, and you can check it out if you want to go more into the details of the technique. Next, we will see how we can apply LAM for text data. So the first step is we have a single instance and we want to generate the text samples. Here I have a sentence. This movie was surprisingly good, and I will perturb it, and by perturb I mean that we just remove a mask words randomly to measure how the predictions change. And after we have the perturbed samples, we will feed them through the classifiers to obtain the predictions for them. And after we have the perturbed samples and predictions from the classifier, we will use them to train a simple interpretable model. And from that model, we will obtain the word importance scores so that we can interpret what are the important words in the sentence that influence the output of the classifier. This technique can be applied for various NLP tasks from sentiment classification to spam detection and topic classification, etc. Now we walk through an example to understand the technique better. In this example, we want to interpret the output of a sentiment classifier. And the first step, we have an input. For instance, I didn't enjoy the movie, but the soundtrack was amazing. And we will fit it into the classifier we have, and it output the probabilities for two classes, positive and negative. And here it outputs 0.68 for the positive class, which means that the classifier thinks that this sentence is a positive review. The next step is to generate the participation and get the predictions for the perturbed text. So here the original sentence we have is I didn't enjoy the movie, but the soundtrack was amazing. So here we just randomly remove a single word or several words in this sentence to obtain some new text. And here, uh, so in this sentence, we just remove the didn't and we will get I enjoyed the movie, but the soundtrack was amazing. And this sentence, when we fit into the classifier, it will put 0.8 for the positive class, which makes sense because we remove the didn't word. And here we see that for this sentence, we remove the entire second clause, and the classifier thinks that is the negative review. These sentences will construct a new dataset so that we will get a new classifier on. The next step is to get the word importance scores by fitting a simple classifier on top of that dataset. After we train a simple classifier on top of the dataset here, we have each word being a feature of the input, and they will have an associated weight. If the word has larger weight, so it will influence the output. in a positive direction, and otherwise, if it has a very negative weight, it will push the score towards the negative direction. Here we see that for the amazing world, it will have very high positive score, and vice versa for hidden. And this technique also has several challenges. First, because we remove word randomly, so the perturbation process may produce unnatural text, and the generated text may never occur in real language. And because we just treat the sentence as a bed of words, the process will ignore the contextual embeddings or the ordering of words and how the word influence with each other. Also, the LAM technique is very sensitive to small changes. In other words, the LAM explanations can vary significantly across runs. And finally, the local approximation with a linear model may be too simple and cannot capture a complex relationship and the true model behavior. Despite of these drawbacks, LAM is still a very useful technique to have in our toolbox because it can help analyze the misclassification of the model and help us gain more insight into the model's output in some sensitive setting like in healthcare or the hiring process. It can also be used to compare the models for fairness and bias. And finally, we can also use it for teaching and for communication with other people or stakeholders. Finally, we have some extra tools and resources so that you can check out if you want to learn more. First is a very popular repo that implements the LAM technique, and we can install and use it via PyPy package. And next is the LAM chapter in the Interpretable machine learning book, which dives into more mathematical and machine learning related details. Now we will see how we can implement the example here in Python code. Now we will see how we can implement the example I mentioned earlier in code. Here is the notebook that I prepared in advance, and you can download it in the description of the video. The first thing we'll need is to do some setup work. First, we need to install the LAM package that I showed you earlier in the GitHub repo, and we'll try to use it to interpret the output of a transformer-based classifier. So we also need to import the transformer package and some extra dependencies like NumPy. And from LAM, we also need to import the LAM text explainer. After we have all the dependencies needed, we'll first need to load our classifier. So the classifier that I'm trying to demonstrate is based on BERT, and here is the link to the model. It's a Python model of the dispute BERT based encased on the IMDb dataset, and you can also load it and test it out in the notebook. After we load the classifier, we just pass the sentence string into the classifier and get the output. Here it gives the sentence, "This movie was absolutely wonderful," as a positive review with very high probability, which means that the model is very confident about its output. Now we will see how we can interpret this classifier on our example. Here is the instance that we have. I didn't enjoy the movie, but the subject was amazing. The first thing we have to do is to define a classifier function that has the required signature. It takes text instances, which can be a list of string or a string, and we have to convert the output of the transformer classifier, for example here, into the format that the LAM explainer expects. So we have to convert it into a NumPy array of negative probability and positive probability. Here are some NumPy code that does the job, and we just return it. After we have the wrapper function, we'll test it on our instance, and it will output the negative and the positive probabilities. So our classifier thinks that this sentence is a positive review. And next we'll define our explainer based on lam. Here we declare an instant explainer being an instance of the lam text explainer class, and we give the class names negative and positive. And after that, we'll generate the explanation for our text instance here. We'll pass it into the first argument and also pass in the wrapper function we created earlier. And finally, the number of features. For text data, the simplest way to define features is just use the separate words in the sentence. So here I use the split function on the text instance and obtain the number of words and use that for the number of features. So for example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 words, so the number of features is also 10. After we have the explanation, let's bring it out to see how it looks like. So as expected, we can see that amazing we have very high positive score and vice versa for the word didn't. And we can also use the S-pie plot figure to generate a plot for the explanation. So we can see that amazing has very high positive score and didn't have the highest negative score. We can also use the show in the book to show the explanation interactively. To summarize, in this video, we have learned how LAM works under the hood and also how to implement the technique in code for text data and for NLP tasks. Thanks for watching. If you learned something new, please push the like button and let me know what you want to learn more in the comment section. See you in the next video.